Problem 5. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it is first weighed, then db dt equals 1/5 times the quantity 100 minus b. Let y equals b of t be the solution to the differential equation above with the initial condition b of 0 equals 20. All right, first thing that I like to do is go through all of my parts, looking at part A, B, and C to figure out which one I'm going to have to cross multiply in, because I'm probably going to. And I notice in part C it does say to use separation of variables to find the particular solution. So that's the only part that I'm going to cross multiply in, so I'm not going to actually solve in any other part. All right, part A. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. All right, well, if I'm talking about how fast the bird is gaining weight, I'm definitely going to be looking at dB dt. So I would like to find dB dt when b equals 40, and then we'll find dB dt when b equals 70, and then we'll compare those two answers. So if I type in this first one at 40, it will be 1/5, 100 minus 40, which will equal 1/5 times 60, which equals 12. Okay, and then dB dt at when b equals 70, it will be 1/5, 100 minus 70, so that will be 1/5 times 30, which is equal to 6. So when is the bird gaining weight faster? Since dB dt of 40 is higher, we know that that's when it's going to happen. So the bird is gaining weight faster when it weighs 40 grams. And then it's said to explain your reasoning, and I'll just say because dB dt when b equals 40 is greater than dB dt when b equals 70. So that's my reasoning. That would have given us 2 points, one for actually using dB dt to get my answer, and then one for the correct reasoning. Right, part B. Find d squared b dt squared in terms of b. Use this to explain why the graph of b cannot resemble the following graph. So first part, second part. So this first part means to take the second derivative. So here we go. The first derivative, this derivative of dB dt, will be that d squared b dt squared. The right side, please keep in mind for this one that the b is representing the y and the t is really representing the x in this problem. So first thing that I will do in this problem is change this to 1/5. I'm going to distribute this to make it a little bit easier. So this is going to be 20 minus 1/5 b. So when I take the derivative of this, the derivative of 20 cancels out. The derivative of negative 1/5 b will be negative 1/5. And please keep in mind that b is acting like the y, and whenever we take the derivative of the y, we do dy dx. So in this case, we will do dB dt. And this one's said to be in terms of b, so we do want to go through and replace the dB dt with what it is. So this will be negative 1/5, and then times dB dt was 1/5 times 100 minus b. And if I simplify that a little bit, it will be negative 1/25, 100 minus b. All right, so that's the first part. And then it says to use that to explain why the graph of b cannot resemble the following graph. All right, so this one right here, if I plug in, this is the second derivative, what actually would lead me to the concavity of the graph. So I notice that any weight in between 20 and 100, when I plug it into this equation, I'm going to get a negative answer, which would mean my graph is going to always be concave down. And you'll notice on this one, I'm concave up like a cup till about right here, and then I'm concave down. So my reasoning is going to be that cannot be a graph. I'm going to say since b is concave down from b equals 20 to 100, and I'll just put in here d squared b over dt squared is negative. then since the graph doesn't match because it is both concave up and down. So that would be my explanation. So for that part would be 2 points, 1 point for getting the correct second derivative, and then 1 point for explaining why the graph cannot resemble that. All right, part C. Use separation of variables to find y equals b of t, the particular solution to the differential equation with initial condition b of 0 equals 20. Okay, on this one, this is the one that we do get to cross multiply because we want to find a particular solution. And when I write this, the 100 minus b really belongs on the top. So when I cross multiply, I'm going to get 5 db equals 100 minus b dt. And I want to get all of my variables on the same side, so I'm going to divide by 100 minus b. And so I'll get 5 over 100 minus b db equals just 1 dt, I suppose. Okay, so now that I have everything matched up, I am going to go ahead and take the integral. A couple things I'm going to do. I'm going to bump this 5 out front. And then the second thing I'm going to do is a u substitution. I'm going to let u equal 100 minus b, which would mean du will equal negative 1 db. So I have the 1, I'm just missing the negative, so negative goes on the inside and outside. So this will be now negative the integral of du over u, and that is equal to the natural log, so it's going to be negative 5 natural log 100 minus b. And then the right side, the integral of 1 is just going to be t plus c. I'm not quite ready to do the logarithm loop yet because I need to get rid of the negative 5, so I'm going to multiply the entire equation by negative 1/5. And when I do that, I'll get the natural log of 100 minus b is equal to negative 1/5 t plus c. I now can do the logarithmic loop, and when I do that, I'm going to get c e to the negative 1/5 t is equal to 100 minus b. Then I'm just going to continue solving this for b. I'll subtract 100 from both sides. And then since I have a negative b, I'm going to multiply the entire equation by negative 1. So I'll get c e to the negative 1/5 t plus 100 is equal to b. And then we do have to use the initial condition b of 0 equals 20. So 0 is my t and b is my 20. So c equals e to the 0 plus 100 equals 20. That will just be 1. So if I subtract 100 from both sides, I'll get c is equal to negative 80. So just finishing this up, I'm going to have b is equal to c, which was negative 80 e to the negative 1/5 t plus 100. And that would have been worth 5 points. We'd get 1 point for separating my variables. We would get 1 point for getting this far right here. We would get 1 point for putting plus c. We'd get 1 point for finding c. And then we get 1 point for getting our final correct answer.